Good afternoon, everyone. Sorry for the reschedule of this session, and welcome to the Tech Talks, and thanks for coming. Right, so my topic is about microservices architecture. There was a similar topic was done by Tamil about serverless architecture, but I just went through to make sure that I'm not doing the same thing. But he basically highlighted about the serverless architecture, not about the microservices. So here during this session we try to dive into architecture, but I'm not using any coding or programs concepts. Basically this is about architecture concepts. This will be a theory session, so it will be boring if I just only speak. So please try to be interactive because it will be very much useful for our future projects. Actually, this was not the original topic that I planned. Why I took this topic after doing some research for the new project that we are doing, for doing Good Hub project. So I found it very interesting, and I believe that it will be very useful to other projects. So that's why I changed the topic. Okay, so let's start with the first. Is it connected? Okay, I'll use the keyboard. All right. Okay, so before we start looking into microservices, first of all, let's see what we do at GVO. Most of the projects, I think, belongs to this architecture, right? So what's this architecture called? It's a normal service-oriented architecture, right? So the characteristics of this architecture is that you build one big monolithic application. So everything is in one container. So what you do is most of the time we keep on adding modules, right? So we are very much familiar with this architecture. So your UI is in the different web application or within the same application. So recently we did a project on AML. So the backend was in one service, but they have been different. UI is different. But if you take a project like TextPro, so you can share. I will take some examples from current projects that I already worked in GVO. So TextPro, which I am a bit familiar with. So the UI might be signed in the same application. Right. So it's a one big monolithic application, right? So is it okay? Now, before we go to talk the positiveness of microservices, we need to think whether this is a bad design. Is this a bad design? Are we going to throw service-oriented architecture, and are we going to adapt to microservices architecture now? So the answer is it depends on your requirements, and it depends on your project requirements. Now this would be the characteristics of monolithic application are like it's very easy to develop, right? Now even when we get the requirements, we actually most of the time we get the template or the solution set up by Robin. So very easily we can quickly do the development. So it's very easy to develop, and I think it's not a very big drama. So we can simple test as well, and easily deployable. So we know how to do the deployments, and scalability is very easy because the infrastructure supports that. So which means the infrastructure is which Microsoft Azure. So you can create any number of instances as you want based on the load. You can configure it. Okay, so everything is perfect. So what's the problem? This is called monolithic hell. Now this happens. Let's say you start with a small module and you keep on adding modules to the same application. Now let's say, for example, okay, again coming back to because I can't take in LAP because it's a very small application. Now you start with a leave system. Let's say we start with the leave system module, and again then we come up with a new idea. We can plug a review system module. So we plug that. All right. Then what? Then we'll get another, let's say, a salary package. Payroll. Okay, payroll module. What do? We plug that module as well. And likewise, so we get document management. So everything is keep on plugging to the thing. Now what happens? So your small application become a monolithic. It's a monstrous monolithic application. The problem. So what are the issues in this approach? When it's become complicated. When it becomes complicated, this issue. Well, obviously the code base is very large. So for a newcomer to start join your team and start learning, it will take a lot of time, right? Because it's very complicated. And because of that, to fix a small thing, the person might have to learn a lot of things and maybe unnecessary things which doesn't need to be going through. Still, he might have to go through. And maybe a small issue, maybe a small feature that you fix might lead to a problem, might cause an issue in other area. Let's say, for example, IPD system. So very complicated system, right? So if you might not know where to create the issue unless you have the unit test written properly. Okay, so that's one thing. And overloaded ID, let's say that of course we can manage if you separate different solutions. But still, if you have in one solution and if you try to load everything at once, it's going to definitely slow down your even starting the loading time of the ID as well. And what else? The larger the application, it's going to take a lot of time to start up. Let's say in your leave system, let's say there are some specific thing that needs to be done during the application startup time. At the same time, you have to do these different things for review system, payroll system, likewise. So it might take, let's say, what if it take like an hour for the startup time? It's not scalable. The reason is that these days the pattern of application is that you might do several releases per day. Right? If you do, let's say, 10 or 15 releases, and if it take 1 hour to start up your application, it's not going to work, right? Most of the time, your application will be offline, right? And obstacle to continuous deployment. That's what I just mentioned. It's very interrelated points. So the deployment also take a lot of time. I think maybe you might have experienced this, right? So it's going to take a lot of time for the deployment process. Why? The reason is that you have one big process. That's the thing. So you have a lot of things to combine, right? You have a lot of things to deploy. So that's going to take a lot of time. There's a lot of overhead. Maybe the change that you did is not relevant to it might be a small change, but still you have to compile all your modules. Am I correct? Right? Okay. What else? Difficult to scale when different modules have conflicting resource requirements. Now, this is actually, now let's say, you have a couple of two modules. One module is CPU. It's a CPU intensive application. It needs more CPU power, which would be more suited to a, let's say, Amazon Elastic Cloud, EC2 cloud environment. But the other module, sibling module, might not, its main concern is the memory, because it might have in-memory database. So there is a conflicting resource requirement. But still, can you separate these modules to, one in CPU optimistic machine and other one in, let's say, memory optimistic machine? Can you do that? In this monolithic application, no, because the reason is everything in one process, right? So you can't do that. So still you have to stick to whatever the infrastructure that you have. And the reliability, this is actually a thing that happened to us very recently. If something goes wrong in one module, your entire application is going to be down. So this happened to us in our annual RP project. So there was a problem in the WebSockets. So as a result, it actually ran out of memory, and from Microsoft, they shut down the service because they detected there's a threat. So what happened? So entire application went down. No one could even log into the system. So it's a small module, but it affects the entire application. Right? So you can see because of these dependencies, it's going to impact. And extremely difficult to adapt to new frameworks. Now let's say, again, A and B modules. A would be the ideal with .NET framework. But B module, to develop B, it would be ideal with Pascal, or let's say Node.js application. But can you do that? Do you have that freedom? No. Still, you have to depend on your deployment environment as well as your initial development strategy, right? So, yeah, okay, again, two more to go. Scaling the application can be difficult. Well, of course, you can scale it horizontally because you can increase the number of instances, but there will be one time your database is going to be a bottleneck, right? No matter how many instances that you have in Azure, your database will have only one database, right? So but still you can't scale your architecture. No, you only can scale your number of instances. And scaling the development team. Let's say, for example, in our organization that we have a leave system, a text program, a team, dedicated team to work with the leave system, dedicated team to work with payroll. It will be a lot of conflicts when different teams working because you are using the same code base and you are using the same database and the same code assemblies. So it's gonna have a lot of issues. So those are the just want to tell you the risk of in this architecture when your application scale, right? Okay. Now, so what are the forces? What are the forces that drive you to move from monolithic to a different architecture? Well, if you have different, as I said earlier, if you want to have different team concepts, it would be better. And team members need to be productive from the beginning, so they can understand the domain. And application. If you need the application needs to be very easy to modify, understand. It's anyway there are common characteristics no matter what architecture you follow. And if you want to let's say take the advantage of different technologies that release, so that things against that I just mentioned against the service-oriented architecture. So if you want to get rid of this, so you definitely need to come up with a different approach. So that's what microservices is for. Well, what is microservice architecture? It's like, I think you can understand it with one single diagram. It's very easy to understand. Here, so you are not having a one big monolithic application. Instead, you will actually refactor those modules. For example, the leave module is leave system module, review system module. Likewise, you refactor it, and it will be an independent application. It can be a REST web API. It can be I don't know, it's some sort of different application, but still it is independent. It will have its own data source, right? It's not necessary to be, but it can have its own database. It can have its own port numbers, endpoints, domains, doesn't matter, right? So it's very independent. So what's the advantage of this kind of an architecture? Is that you focus on this only in this area. You don't need to worry about other areas at all. There's no connection, there's no communication between these applications, right? So if you want to do the communication, right, there are ways to do that. So I will cover that in the upcoming section. But these are autonomous services standalone. Okay. To elaborate it more, this will be another diagram which we can see. This is something interesting. This called API gateway. So we'll come to that once this for. This is a very important element in a microservices architecture. Right. So clients communicate through the API gateway and reach whatever services that it wants. All right. Okay. Application scalability. Now, in our current applications, it can grow in this way, right? Where you can increase the number of instances by cloning the virtual machines. Maybe simply can clone the virtual machines, right? So you can have your number of instances, but it's going to be a bottleneck. Now, in microservice architecture, you can go in this Y direction, scalability, as well as Z direction, which is Y-axis means that your architecture can be scalable. You can plug different applications. So it's a scalable architecture as well as scalable from the data partitioning aspect. So you have your own different data sources. So now you can see the architecture, how it's being evolved and how useful it is. Okay, right. So please, if you have any concern, just be interactive. Otherwise, it would be really boring. Okay. Services, microservices, yeah.
So that means we are same database, we are not accessing same database in the given entity. So that means for one service, we have separate database with their relevant data.
Exactly.
And another, so what happens if we want to communicate between those databases? That means the second service, second application needs some data from the
Right.
database.
Yes. Yes. That's a good point. Now the thing is that when you are designing your microservices, you need to minimize those, right? But practically, we can't do that, right? 100% you can't do that. Let's say if one, for example, let's say this account service, if it needs to, if every time it needs to access, for example, inventory service, let's say to access inventory database, then there's a problem in the design, which means these two cannot, be independent. That's a problem in the design. So then you have to merge those two together. Either you have to make it one service, or if you want to communicate, there are ways to get the data. So either you have to do a synchronous call or synchronous communication. So synchronous means you can directly do HTTP call, which is not the correct way at all. Asynchronous means you can use sort of mediators or service buses or everything, and you can get the data. Or else you can duplicate the data that in this inventory DB in the account DB as well. So it is perfectly okay. Don't think that because there's a duplication in the data is a bad design. No. You can have, let's say for example, the person, the best example, the person can sit in this database or this database. But the attributes that person might have in this microservice context is different, might be different from the attributes that it has in the account DB context. So let's say for account, maybe you might only interested in first name and last. Here, maybe the address. Right? Now, there has to be a way to synchronize the data. Now, let's say if a person we added, let's say the original person data is here. If you create a person, you should be able to communicate that to other services to say that, hey, I created a person, so if you want, you can update the repository. So that I will discuss the next stage.
Means again it is a dependency between one services and other services, right?
No. How can the dependency be there? Because you have your own data. Now let's say if you want to access some person data, so you have your own copy. So you are not asking someone else to give that information. But let's say if the person database got the new person, that of course needs to be notified to others so then they will update. It happens behind the scene. There's no direct dependency. Okay, now coming back to what you asked, Rajita, so how we are going to design that? How you are going to decide your microservice scope? It's very easy. There's a design pattern called domain-driven development. You might have heard about it, DDD. But I haven't gone through this one. But I think Ravin knows much better than me. There are a lot of these are new concepts which you should use. Here you basically draw your entities, domains, and then you define your boundaries so that with minimum dependency. Now you can see the product entity is in both contexts. That's fine. Right? So you draw your boundary. So that boundary will be your context that become your microservice. So this is how you design your microservice from your business domain. Okay, so this actually will come from your gut feelings as well as your experience. So yeah. Now yeah.
First question, duplicating data. Duplicate data, whereas we could go with the monolithic application and only one copy of data, and we don't need to see data, like we don't need to retrieve additional data. But the reason we have to do microservices architecture is only doing that gives you more benefits than the overhead of introducing these is some areas you will have to introduce these service buses, e-commerce communication, and data duplication, but you have to break down your components in a way that such overheads are minimal. And after going to the microservice architecture, you have to be able to justify that overhead because you are gaining on a lot of other areas. Independence, you will be able to fix bugs without affecting other areas. That's a question you have to ask yourself. And if you blindly do microservices without thinking about the benefits, then you will only end up with introducing more overhead to your system.
Yeah,
you shouldn't do that.
So that's the thing. Now, if your application, you know your application scalability. If you can't really draw a boundary, so there's no point of having that kind of a costly architecture. That's actually something that reminds me something. I forgot to mention about this. Some theories which you use. It's called CAP theorem. CAP theorem is a computer science theory that you use. If you have two options, which want to be taken. Sorry. Now, for example, if you are duplicating data like this, you have to think what are the options, what are the benefits that you get. Now, for example, now once you duplicate data, the problems are like the consistency, right? You might update this one, but not this one. Of course, right? So you might have a new product here. Maybe you have to sync it to here, right? So that's one decision to make. Another thing is availability, right? Whether to keep your services up and running. So you have to make a decision whether you prefer availability or the consistency. So in microservices world, they prefer availability than consistency. Consistency will happen eventually. Sometime it will happen. At the end of the day, it will happen somehow. It's not how far it is, how fast is it. So availability means you are independent. Your independent services stand up. So don't worry about the consistency of the data. So that's a theory. And other things are called two-phase protocol. Now you may have studied about the two-phase protocol, but that's something in a distributed architecture. So how you are going to keep your data consistent? Unfortunately, two-phase protocol is not supported in a lot of noise to your databases, right? So you can't look at two-phase implementation. So those are some theories which I found during this research part. Okay, now again the one that I just mentioned. So here, how to have the consistency between shipping and product. So basically, you tell your let's say product service. You tell that okay, product being created to people who are subscribed to product. If it makes confused, please raise the question. Right. Coming back to something, API gateway. Now microservices, there are two approaches to expose your microservices. One approach would be to expose your microservices directly to outside world, which is not the best approach. Another one would be not to expose your microservices directly, but to go through an API gateway. So your microservices would be behind the scene. No one can even see that, but they will only, your clients will only communicate with the API gateway. So there are a lot of reasons behind this. Let's say, if you want to implement security, so then you have a huge cost in each layer. You have to say the same thing in each and every service. So if you move it to a common service like this, so you can see that advantage. These are very primary things what I mean, but I included all the features in different slides. Yeah, common things that we can do. No, if it is business things, no. This API is like products. There are already real products. In Microsoft Azure, they have Azure API gateway, and WSO2 they have their own API gateway, and Amazon they have API gateway. So there are products. So it's like plugging purchase, and then so you can't plug in business logics there. It's like more like a load balancer, I would say, because there are similarities in a load balancer and API gateway, but they slightly differ. So is it clear? This is what happens here. Okay, when to use an API gateway, like so it's like if you have a cross-cutting concern like authentication, data transformation. Like let's say if your microservice is not a HTTP, it's not exposing the services via REST API. Let's say now clients, how do we usually connect to backend services? We use HTTP calls, right? What if the service does not provide that protocol? What if that service is not that protocol friendly? It might have a I don't know, MQTT protocol or whatever implementation which you cannot communicate directly. So in that case, it's more advisable for you to go to the API gateway. API gateway will do this transformation of data. So you only make a HTTP REST call to the API gateway, right? Got it? I'm not now this one. The things that I have taken are not specifically on. Yes.
If you are writing an API gateway,
Yes.
you can write available stuff. You want to keep
what I'm saying is that some of the now say WSO2 API gateway, they might provide certain features which are not supported by Azure API gateway. So this is a common thing which I do, which supports one of the out of the box features that support by them. Okay. Now the features are like this. Don't this is just for your knowledge. This is called canary releases. It is like this. Now let's say you have a API 1.00 and you released a version for 1.0.1. Now you don't want to flow your entire traffic to this API service. You want to just test that. Let's say this is a live system. You might want to have 10% of your traffic to go to this service, just to make sure that it's okay. Then what you want to do, complete shut this down. So then you can translate 100% traffic to this service. So that capability is there. Load balancing. It acts as a load balancer, but there are differences between a load balancer and a application gateway. Well, load balancer acts in the transport layer. In application layer, we have learned this transport layer application likewise. So it basically operates on these protocols, TCP, and application gateways, they act with HTTP protocol. It's application layer protocols like web servers, HTTPS. To be honest, I have no idea about this feature. Well, this is called load balancing mode, like how we picks the correct virtual machine or the device. Let's say this is a packet, how it is going to find the relevant candidate to transfer the request to. So it's a, for example, this is like the source IP, source port, destination IP. So based on these parameters, it picks a random, generates a random number and connect to that service. And application gateway is a round robin algorithm. Likewise, so SSL offloading is something what we point out that this is called SSL termination. So SSL termination does not happen in a Azure load balancer. You can't do that, but it only supported by application gateway. So those are the few differences between it's API gateway, named as application gateway in Azure, but it's the same product.
Basic load balancer.
Exactly. Right. Okay. This is called blue-green deployments, which I believe. Okay, now it's like you can can hide this after the, I think this is very much similar to what I just mentioned earlier. So you can completely hide your point. After some time, you can switch to the new release. Okay, so those are out of the features that are supported by API gateways. It's just for my reference. Okay, now challenges and solutions. What are the challenges in a distributed environment? First, the biggest challenge that you will encounter is that how to design this bound context. The one that I showed you earlier, the clear separation, is the difficult part. Because sometimes you might think that this falls into this microservices, and later you found that it would be better to put it to other services. Right? Maybe you might find that, okay, I need to duplicate these things. So that call, maybe when you become mature with this architecture, you will, otherwise initially you will have to spend a lot of time on drawing the boundary. So there are a lot of text because I just took it for my easiness. Otherwise, it's a lot of things to remember. From here. So that's fine. Don't need to worry about reading entire thing. Okay. Okay. I think this is what something related to what we just discussed. If design involves constantly aggregating information from multiple microservices, which means that if you want to do a query, and if that query involves talking to different microservices, that's a problem. So that's a bad design. Okay, what's the second challenge? Queries that retrieve data from several microservices. Like let's say now if you have data which you need to take it from different microservices, so it's a challenge, right? In monolithic application, how we do is that we just write one single link query and we get the data, but we go after the query. But here you can't do that. Maybe you can do that from the API gateway. So API gateway can sometimes it can aggregate data. It can call different services and it can combine it and it can send the client data. For example, take a mobile application. So mobile dashboard will have different data to be taken from different sources. So you can only make one call to the API gateway, and API gateway does that magical aggregation and will send you one response. But that's a bad design. It will be an issue. It will become a choke point where your everything load becomes to the load API gateway. That's a problem. And so in order to overcome that, these are the options available. So API gateway is one solution. This other one would call other things you can, if you have common queries, then simply you can have a different database so that your requests come to that service and it will get the data rather than fetching data from different sources. So you will have one database with all these tables. It will definitely be duplicate data, but that's fine. Use your report service, for example. Let's say report service will fetch the data from that report microservice and call data in central databases. It's like you don't need to put hot data. Again, something that is much similar to this approach. You are not going to put your latest data to a different database. This is called hot data. But eventually, at the end of the day, maybe you can do a batch transfer. So then you can take that data from that database. That database will contain all the data from different services. So these are the approaches available. And how to achieve consistency across multiple microservices here. So you see now, never call to this service. This is a bad design. The cap theorem that I just mentioned earlier. So there are ways to do that. So we'll discuss it later. And how to communicate. Now, HTTP based direct microservice to microservice communication is not advisable. So either you have to use message queues or to minimize, because now let's say now one request arrives and that request wants to now let's say it comes to the account service. Now account service microservice wants to communicate to the product microservice. Now product microservice, in order to fulfill that requirement, it needs to talk to another service. Like let's say it's like a chain, right? So it's not a good design. You should not let that happen. Chain of actions should not be happen in a microservice architecture. Okay. So how can you communicate microservice in a microservice architecture? So there are protocols. So there are. In order to discuss that, first of all, we need to understand what are the communication types like. synchronous protocol and asynchronous protocol. Synchronous protocols are like HTTP. What's a synchronous protocol? So it's like you request, but you wait for the response, right? Either you can go. These are available communication types, or asynchronous. You put a message to a message queue, you forget about it, fire and forget. So those are the available communication types, and the second axis is like whether this is a single point-to-point communication or this is a publisher-subscriber, like a lot of receivers. So these are the things just to consider when you are designing your communication. So these are the available options. All the available options when microservice communication needs to be taken place. So if it is a single receiver, it would be the command pattern, which maybe you can discuss it about how it happens, the command pattern. Or you can have multiple receivers. So here, multiple receivers go by single sender. So there you can have the event-driven architecture where you have maybe the service bus would be the ideal. But Ravi recently found that there's a new component in Microsoft Azure called event grid. Not the event hub. Yes. So event grid is a new component which supports this to publish data to multiple receivers. Okay. Right. So the communication channel, if you take, so this is an anti-pattern. So what are the patterns available? What's an anti-pattern? So that which is something that you should avoid. Which is like, let's say you have a client and you try to make a call to this basket service, and the basket service needs to get you have to do that. They probably make an ordering service. I don't know. Like it's more like a chain. You should not be happy. You have to avoid that. So either you can have asynchronous communication. So let's say client request arrives. So it's not going to talk to ordering service. Rather, it will put a message from the bus, service bus or something, so that it will ping and it will process. If it needs to process real-time analog, it will have a message to the service bus. It will not do a direct communication. Or else you can do polling. Polling is that time to time you keep on requesting data. This is a recommended way to communicate with the microservices. Polling or asynchronous communication. Right. Okay, this is about the same thing. Again, how you are going to publish to multiple parties. So you use the event bus, service bus, and you, so there are subscribers. You pass your messages like this. These are okay. So I think so we reached the end of the microservices architecture, right? So let's talk about the benefits of this architecture. Well, I think whatever the things that we saw as bad is being addressed from microservices. So, I think the biggest advantage that I see is that you can deploy your microservices independently, right? If you make a change in the say new system microservice, you are not worrying about other review system or anything. So it's that much easy, and the deployments are very quickly, and because it's a small area, and the application startup times starts very quickly. And you can use the best hardware which suits your services. It can be again a CPU intensive operation server or a memory optimized server. Yeah. So what are the drawbacks? Now, is it easy to implement? I think the biggest concern is this. Like when we as a team, when we were discussing, like it's a bit challenging. It's not very straightforward, right? It's very costly, right? You need to have a lot of databases. You need to have your different service plans, right? Service bus, unnecessary thing. That's why Ravin, I think that's what he also pointed out. If it doesn't, suit you, no point of going to that. It's very costly, and especially if your client needs to agree. Unfortunately, our client agrees with that. He understood the things, but if the client is concerned on that cost, definitely you can't go with the microservices architecture. Yeah. So just to tell these references, this reference is actually it's one of the best references that I read. This is from Microsoft. We actually, as a team, we refer this document. There are a lot of good design patterns that we should follow out there, and yeah, so there are even source code. There's a small GitHub project that they did the project structure, how to do design the project, your architecture with Microsoft Visual Studio. So they are there, so you can refer to them. So if you are interested in just the first one is the most important thing, you can go through that one. Right, I think we can wrap up we can end up in the session. If you have any questions, please feel free to ask. Otherwise, we can stop. Okay, thank you very much.